Hi everyone, Steve Goodwin here with anchor test video number 131. Today we'll look at this Rocna Vulcan anchor. It's advertised at 20 kilogram or 44 pounds. However, it came out at 47 pounds on my scale, and when in the setting position, the tip came out at 18 pounds. That gives us a tip to total weight ratio of 38%, which is a little better than average. Now, the chain attach hole is very well engineered. Any conceivable shackle that you may wish to pass through here to connect your chain will fit no problem. Overall construction, I like it. It ticks pretty much all of my boxes. In that, there is no hollow spaces. We have no hollow roll bars, no hollow shanks. There's no connections. There's no bolts, no places, no laps or gaps where material like seabed and mud can fester and cause corrosion problems. There's no movement. It is built in a couple pieces of metal, but it's very generously welded together. The shank is such a shape such that it will self-launch extremely rapidly from your bow roller. These Vulcan anchors probably have the highest self-launching power of any anchor that I have tested. What this means is if you've got your windlass or anchor chain handling gear well aft of the bow roller, that means when you let go of the chain, this anchor will launch and it'll drag a lot of chain with it. So you'll never have to go up and give this anchor a kick to deploy the anchor. Another thing that's pretty cool about these Vulcans is the part of the fluke here in the back is totally smooth and there's nothing to catch on anything. And the thing that comes to mind, if you're not familiar with classic sailboat sort of bows, they often have a bowsprit with a bow roller right alongside the sprit. It's a very convenient place to handle your anchor. However, bowspritted boats also have a bobstay, which is a stay or a wire rope that extends from the tip of the bowsprit down to the hull near the waterline. And anchors that have sort of an edge or a protrusion along the back have the tendency to catch on the bobstay. So you want something that's very smooth, so as the anchor is deployed, it will sort of worry its way past that stay without getting hung up. Now, most of you will recall that I have thoroughly tested a 9 kilogram Vulcan. That one gets compared to the 20-pound range anchors up here on the wall. Previously, you may recall, I also tested a 55-pound Vulcan. That was a loaner anchor, and it really didn't fit into my 45-pound range of anchors. So that I no longer have that anchor, and I struck all of its data from my charts, some months ago. But now we have the correct size Vulcan to include with those 45-pounders. Let's go see how it did on the seafloor.
We'll get things started with the 180-degree reset test in the sandy mud. Scope is 5:1. I used 80 feet of 5/16 chain and the balanced nylon. Initial sets are just perfect. And frankly, all these resets I'm going to show you, I'll give you all 10. They're just about perfect as well. We do get one back flip and a little bit longer reset distance, but you see right there, the anchor was over on its side just a little bit, but basically remained engaged and just rotated on around. That time maybe it moved maybe 2 anchor lengths, but again, overall it's really, really good performance. There are a handful of anchors that I think are maybe just a tiny bit better. The goal of this test, well, at least when I started doing it, was to see whether or not an anchor would foul with mud just based on a typical initial setting, and then when it released, would it reset. And there was a couple anchors early in my early testing days that just sometimes they would not reset at all. You could drag them as long as you want, maybe even just you could stop the boat, stop the anchor, and restart and just be as gentle as possible. Once those had loaded up with mud, they were basically hopeless. But it's not the case here. This anchor really does well. That was I think that might have been the second longest drag, maybe 3 anchor lengths there. And here's the back flip. You can see the chain pulling the anchor right upside down. That was a little bit longer, maybe 4 or 5 anchor lengths, and it just hooked up, stopped the boat. I'm giving the anchor a good burst of power after the reset, over 500 pounds of force. The boat does drive up and over at 3.5 knots on each one of those, so I'm just trying to be as violent as I can and expose any weaknesses that may be present. But for this anchor and this seabed, at least at this scope and road combination, there was no problem. Next is a straight line resistance test with the winch in the sandy mud. It's 5-to-1 scope with only 12 feet of chain. The balance is just Dyneema. And again, I'm winding this anchor toward a deadman anchor using a winch. A deadman anchor is a Fortress FX85, and it is also moving undoubtedly because it has to set as well. And so it's kind of a war between two anchors. You'll see here that toward the end, when this is up near its maximum, it's really not moving much at all. It never stops moving completely, but I'm assuming that the deadman anchor is also sort of inching along as well. This anchor does extremely well in this test. In fact, it maxes out my equipment. There's a lot of other anchors in this size range that cannot produce anywhere near this kind of resistance, and also lots of anchors that will roll out, pop out, or otherwise become disengaged. But this anchor never does anything like that. It just ramps right on up. You see in the lower left there, those are in pounds. That's the resistance or the load on the anchor rods. I normally stop things at 5,000 pounds for safety reasons, but I went ahead and let it go a little further. Went ahead and let it go up to 5,300 pounds and then stop the test. Next is a repeat of that winch test, and it was a repeat of the performance as well. The anchor buries immediately, and it was out of sight the whole time. It never showed any evidence that it was listing, no rollouts, no pop-outs. Just stayed perfectly engaged and made tremendous resistance. I did not quite make it to 5,300 pounds this time. It touched 5,000 once and then hovered there for quite a long distance. Cut things off eventually just to preserve the equipment. But just a brilliant performance. We see there that everything is just a straight line. Anchors that are listing at this stage will show seabeds sort of pushing up and cracking off to one side, but we'll notice there in the bottom of the screen we've got cracks in the seabed showing on both sides. Incidentally, 5,000 pounds of pull by my estimate, and it's a fairly loose estimate, for a boat like mine, which is a 35-foot sailboat of about 7 tons, I estimate it at about 80 knots. For 5,000 pounds. So gives you an idea. This might be a small hurricane type force, and if it was this seabed, well, that would be a fairly secure way to immobilize your boat. Last test for the sandy mud seabed is a veering test. This is at 7-to-1 scope with a rope-only rode. The boat is pointing away from the anchor, and I'm just using propeller thrust. After ramping thrust up to 860 pounds, I just cock the steering of the engine to one side a bit, and the boat starts drifting, this case to starboard, at about 1.5 knots. I let this continue through 180 degrees, and we just watch and see what happens. We are watching the playback at 8 times camera speed. Makes it easier to see the relative motion, but as you can see, there is very little motion. This anchor is doing extremely well, just pivoting right within its own anchor length. However, at the end of the 180 degrees, I straighten out the engine and ramp up power to 1,350 pounds, and we see a bit of motion. The very best anchors could stay just absolutely put, but motion did settle down, and the anchor ended up doing really quite well. Next is a straight line holding power check in the Cobblestone seabed. This is a very consistent seabed. It just has the same size cobble up to about grapefruit size, just continuously along this, say quarter-mile stretch of beach. I don't pull that far. I usually go, maybe about 200, maybe 300 feet. And the anchors will typically engage and then release rhythmically right up near their maximum potential. The number that I use for their holding is the number, or is the pulling force that results in zero movement. This is one of the few seabeds where you actually get a true holding anchor. It will just be not moving at its best. And what it did, its best non-moving holding was about 395 pounds of force. If I bumped up the power to the next RPM increment, which was 465 pounds, the anchor would begin moving again. And right here was the best it did. You can see the fluke was fully buried, not terribly deeply. At least it was covered with stones, and down below you can see there is some sand mixed in with the stones. But again, at 395 pounds, the anchor was stationary, and then above that it would start creeping ahead, and eventually it would release completely. And the beauty of this test is I can, in one pull along this beach, I can get multiple sets and resets. The anchor never fouls here. Obviously this rock just sort of falls off the anchor, and it can reset itself. And again, I can commence multiple sets and resets in one pull, and it repeats itself incredibly regularly. This has to be my most repeatable and consistent seabed that I use. Anchors will just set, reset, and repeat their performance over and over all along this beach. So about 400 pounds of holding puts this anchor, I'd say, in the upper middle of the pack for this size range of anchor in this Cobblestone seabed. Next is testing in the soft mud. Unfortunately, the underwater camera here just shuts off just shortly after hitting the bottom. Not sure if the battery was dead or what happened, but right now that camera just quits working. So we'll finish things off with the topside footage. What I've done here is I've set the anchor in a straight line at 535 pounds of thrust, and you see I've just moved the engine off to the side, and then the boat starts walking to port, and I let it travel all the way around through 180 degrees, and I watch the GPS, I watch the little sort of snail trail or tick marks on the page there to make sure that the arc that the boat is transcribing is a nice semicircle. We're looking at the wake off to the left side there. We can see that we're not really moving ahead at all. We're just moving sideways, so I call that a really good veer. It would have been nice to back that up with some visuals, but frankly, this seabed is extremely difficult to film even when the camera does stay going, because more often than not, cameras do become captured and they plunge down and we don't see much. Now I've straightened out the engine and I'm just pulling in a straight line after that veer, and I'm ramping up power to see how much the anchor will resist. And that number was 790 pounds. So with 0 GPS speed, nice and solid 790 pounds. But then when I bumped up power to 860 pounds, the anchor began a slow movement. The boat was increasing speed, and then as always in this seabed with this test, when it reaches 2 knots, I cut things off. So 860 pounds, it was going to either stay moving at some high drag rate or possibly release, but again, cut it off at 2 knots, and then I let the anchor reset with no thrust, and I just start all over in a straight line and see what the anchor can do on a reset. And this anchor did reset right away, and it didn't quite make as much holding on that try. It was moving 2 knots at 790 pounds, and it was solid at 685 pounds. So let's call the resetting excellent and the veer excellent. The straight line holding or resistance was as good or better in terms of other steel, non-roll bar, non-pivoting fluke anchors. As we know, the roll bar anchors do much better here in this soft mud. And then, of course, the very best here are the pivoting fluke, Danforth, or Fortress style anchors. That was a release at 34, so good reset, but not quite as much. Last test is over in the clean sand seabed. This is a veer check, 5-to-1 scope with the long chain at 860 pounds of thrust. We're going to show this to you at 4 times camera speed. Initial set is great. Straight line up to 860 is very little motion. Anchor does bury itself nicely, and it completes the first half of that veer really, really well. While we watch this first half, I'll mention that I did get called out in the comments of another video regarding this seabed. Someone pointed out that it was wrong of me to call this a clean sand seabed when we know that it has a binder down below at some depth. And it actually brings up a good point, and that is, say you come to a new anchorage and either you look down or maybe you swim down and you find clean sand. How do you know that it is clean sand all the way down? You may think, okay, I see clean sand. I'm going to break out my trusty clean sand anchor. Well, if it is not clean all the way down, maybe that anchor will be subpar performance. Anyway, just food for thought. So this is the point here where the anchor starts moving. It was more than halfway through the veer. It did start moving. Now we can see part of the shank becoming visible. So the anchor lifted up, and it looked like it had a little bit of a list. It did move some. Now, the very best anchors in this test don't go anywhere. They pivot on around, and you really can't get them to move much at all. But all's not lost. This anchor, in spite of that even more speed, it settles back down, does rebury itself, and finishes off with just very, very little motion. So it's certainly a very successful test for this anchor, but it was not perfect. Here's the latest 45-pound anchor performance graph. We have 3 seabeds represented: sandy mud in blue, soft mud in green, cobblestone in red. To my eye, the big story is the vast difference in performance between the sandy mud and the soft mud. The cobblestone holding is arguably, pretty unlikely to be encountered unless you're in an area that has cobblestone. It's reasonable to probably discount those numbers. But the other 2 seabeds are likely to be encountered in many areas of the world, or I should say seabeds similar to those. And there's kind of 2 philosophies that one could adopt. One would say, hey, unless you see a storm coming, you don't really need to worry about those tremendously high sandy mud numbers that many anchors have. Maybe they may say you should really focus on the soft mud performance, since that's what's so marginal. You better pick the best one out of that group. Another philosophy would say, hey, all of those soft mud numbers are so marginal, we should just forget about them, and when we get to soft mud, we'll use our specialty soft mud anchor like a Danforth or Fortress. And then that's a perfectly sound logic. My question to that second philosophy would be, how do you know you are going to be in soft mud? So for the anchor of the day, the 47-pound Vulcan, we see it there second from the left. It's just behind the Vulcan in total average performance on this graph. You can see it's just towering amount of sandy mud performance. Pretty good performance relatively in the soft mud, and decent in the cobblestone. Here's the latest 45-pound anchor ranking chart. And right off the top, we see the 47-pound Vulcan at the top of the chart. That is the new best anchor in terms of this figure. Formerly, the Excel number 5 occupied the top spot since pretty much the inception of these charts. And then just recently, just a couple weeks ago, the Viking 20 moved into the top spot after that sandy mud winch shootout. But now the Vulcan has displaced that Viking. In terms of total average, it's by a good margin there. The Vulcan is a 4.3, Viking at 4.1. The performance average, however, the Viking 20 still dominates. It's nearly perfect or nearly best in every category. The Vulcan is certainly no slouch. It does very well. It's only got 1 3 rating in the performance, and only 1 3 rating over in those other categories. So it just overall either does very good or excellent.
Well, I see no reason to doubt the Vulcan's position at the top of my ranking charts. It really did well. As you saw, it either was good or excellent across the board. No bad habits. Just a great anchor. Now, my testing is not the end all. There's lots of seabeds around the world that could be very, very different from where I test. So you're going to have to rely on perhaps some other people's tests or claims as to how their anchors work in these other parts of the world. So if you held a gun to my head and asked me to say something bad about the anchor, here's all I got. And it's not terrible, it's just a nitpick. And that is that when these anchors are in the bow roller stowed, the roller is, say, up here in this neighborhood. And you've got all this weight hanging way down below it, and there's just not a lot keeping the anchor from twisting. As the boat jostles around, these anchors oscillate a lot. So they require having a line pulling off to one side, or maybe some bumpers or special chocks for the anchor to be secure in. And frankly, most anchors need that same treatment. It's just that this one, from my view, seems to be a bit more unwieldy in that situation. Well, I hope you got something useful out of the test. I'm Steve Goodwin. So long.